Algebra students, welcome to part 2 of simplifying rational expressions. Now in this part here, I'm going to add one more step to what we talked about in part 1. And that's that, here's this one common link, is that fractions are factored before reducing occurs. So sometimes we might have to do a little extra work before we can start reducing. So what I mean by that is look at these two expressions here. And this is problem 10-4 from your book. I want you to look at the one on the left. That's one we're going to talk about first. We have x squared plus x plus 3 over x plus 3. Now again, I'm going to go back to this common link. Fractions are factored before reducing occurs. X squared plus x plus 3, if you tried to put that in the box diamond, you could not factor it. Remember, the box diamond factors these. And in other words, it writes it as a product. We can't write this one as a product. It's not factored, and it won't factor, and therefore we can't reduce this. Now, one common mistake I just want to note here is that a lot of students like to try and cancel out, the x's in this case, or they try to cancel out the 3's. Common mistake. You cannot create a big 1 out of these. You cannot create a big 1 if it's not factored. If it's not factored, okay? So you cannot cancel these out. I cannot repeat myself enough. The answer here is not x squared. The answer is x squared plus x plus 3 over x plus 3. Now differently, I'm going to look at this one over here, all right? It is factored because these are written as a product. So now I can go ahead and look for these groups, right? When I have parentheses around something, it's grouped. And even if it doesn't have parentheses around it, that means this whole bottom part has its own set of invisible parentheses. So I now see two groups that are the same. I can make a 1, which means I can cancel these out. And when I cancel these out, they don't go away, remember? They just become 1, right? So I'm left with x plus 3. I'm replacing them with 1. So I'm left with x plus 1 over 1, which is just x plus 1. So now it's factored. Now it's reduced. I'm sorry. It was factored. Now I've reduced it. Here is the reduced, simplified, rational expression. So again, we're looking at problems that are coming from your book, and problem 10-4, which is the problem we just looked at, you may have noticed that the numerator and denominator at the top and the bottom of an algebraic fraction must both be written as a product before any terms create a 1. Examine the expressions below. Factor the numerator and denominator of each fraction if necessary. Remember that one on the left, we couldn't factor it, and that's okay sometimes. That is, rewrite each one as a product. Then look for 1's and simplify. For each expression, assume the denominator is not 0. So here is one way I like to organize it. All the math teachers here like to organize it. So we're just going to take it one piece of this at a time. So this is not factored, but we want to make it factored. So we're just going to factor the top, which is x squared plus 6x plus 9, which means I want to put this into a box diamond. So I'm going to draw my box. In the left-hand corner goes my x squared. In the top right corner goes 9. I'm now ready to make my diamond, which is 9x squared. 6x, what two numbers multiply to get 9x squared and add to get 6x? That's 3x and 3x. Fill that in. X plus 3, x plus 3. I can now replace the top with its factored form, x plus 3 times x plus 3. I've now written the top as a product. All right, now I'm going to work on the bottom, okay? X squared minus 9. This is one of those special cases. It has a name. Difference of squares. Difference of squares, there's that shortcut, right? I can write x squared minus 9. In its factored form is x minus 3, x plus 3. You do not need the box diamond for this. It's a special case, difference of squares. Well, now I've got my top, I've got my bottom. I'm going to move over to this box and rewrite my original expression in its factored form. So I'm going to take the top, which was x plus 3 times x plus 3. I'm going to rewrite the bottom now, which was x minus 3 times x plus 3. I can now look for my giant ones because I have the top written as a product and I have the bottom written as a product, right? The numerator and the denominator. And I see a giant 1 right here, right? That gives me the ability to cancel these out. I am left with x plus 3 over x minus 3. No, you cannot cancel out those x's. You cannot cancel out those 3's. The top and the bottom are different. So this is my final answer, x plus 3 over x minus 3. And that's it. That's the answer. So let's try another one. Again, we're going to organize this in this really nice organizer here. So we're first going to factor 2x squared minus x minus 10. Put it in my box diamond. The 2x squared is going to go in the bottom left corner, while the negative 10 is going in the top right corner. Make my diamond. The top is negative 20x squared. It needs to add up to negative x. What two numbers multiply to get you negative 20x squared and add to get negative x? That will be negative 5x and 4x. Put those back in my box. This would have to be 2x. This would have got to be x. Put the minus 5 there. 2 here. The top's factored form is 2x minus 5 times x plus 2. So I will be able to replace the top with this right here. Moving on to the bottom. All right, 3x squared plus 7x plus 2. Make my box here. 3x squared going down here in the bottom left-hand corner. In the top, I've got 2. I need two numbers that add to get me 6x squared and, multiply to get me 6x squared and add to get me 7x. That's going to be 6x and x. Fill those in. Going to put my 3x here and my x here. That means this here is 2. This here is 1. The factored form of my top is 3x plus 1 times x plus 2. I am now ready to replace my top and bottom and write my factored form of this rational expression. All right, so my factored form is 2x minus 5 times x plus 2. It's the top written as a product. And the bottom here was 3x plus 1 times x plus 2. That's the bottom as a product. I now see my giant 1. Here it is. Meaning I can cancel out the x plus 2 on the top and the x plus 2 on the bottom. That leaves me with my final answer of 2x minus 5. 3x plus 1. That is it. That's my answer. That is the simplified version of my original, right? These are a simplified version of this original one. They're the same. All right, let's move on to this one. And I really want you to think about this before you try to factor the top and the bottom. Look at it real close. What do you notice? Here's the expression on the top. Here's the expression on the bottom. What do you notice? They're the same. And if something's the same on the top and the bottom in fractions, what does that mean? The answer is 1. Do you need this big thing to go factor the top and the bottom? No, don't waste your time on that. Look at the top and the bottom. They're the exact same. The answer is 1. You do not need to go through and factor everything on the top and the bottom. You can, but you're going to see that everything's going to cancel out. You're going to find two big ones and it's going to cancel out to 1. Here's something else you might see on the top and the bottom. I'm going to factor the top. I've got x squared plus 4x on the top. The first thing you should always look for when you are factoring is a GCF. On the top, the GCF is x, right? The GCF is x. So if I plug this into this generic rectangle, x times what gets me x squared? That would be x. X times what gets me 4x? That would be 4. So the factored form of the top would be x times x plus 4, right? Isn't this the same thing that's on the top if you distributed this x back in? Gonna do the same thing for the bottom. Do you see a GCF? Good. The GCF is 2. So again, I'm going to fill out this generic rectangle. 2 times what gets me at 2x? That would be x. 2 times what gets me 8? That would be 4. I'm going to rewrite the bottom as 2 times x plus 4. If you distributed this 2 back in, wouldn't it be the same as the original way we wrote the bottom? Yes, it would. So I'm going to write my factored form. Got x times x plus 4 over, the bottom over here was 2 times x plus 4. Here's my big one. Cancel those out. My final answer is x over 2. All right, that's it for today. If you have any questions, reach out to your teacher. We'd be happy to answer. Good luck with your Delta Math assignments.